Okay, 4.1 with theory of bonding. So we know for OH2 how to graph that, draw that. So oxygen has 6 valence electron, 1, 2, 3, 4, 5, 6. And you have hydrogen has 1 valence electron. Hydrogen has 1 valence electron. And these two will be shared. So we have bound here and we have bound here. So as you see, this is like a band because you have a 2 lone pair in the center atom. Same thing for NH3 and 1, 2, 3, 4, 5 valence electron. Hydrogen has 1 valence electron. As you see here, they share electron to make a bond. So this electron will be shared with that, make a bond. Here you have a bond, here you have a bond. As the most of them is non-metal, so we have a covalent bond between them, which is sharing. The same thing with C. C has 4 central electrons, so each will be 1 bound with the hydrogen, so CH4. So let's do the C key idea for the Lewis theory. Atoms and ions are stable. They have a noble gas like. See, oxygen now, it becomes 8 electrons around it, right? So atoms by itself wanted to make 8 electrons around it. So 2 here, 4, and 2 here, and to make sure this electron from hydrogen is shared with that. So each bound is 2 electrons. So totally 8 electrons around oxygen, so it's octet rule. Elements are most stable when they are paired. So as you see, these 2 electrons paired, so they are stable, right? Also, these 2 will, when they make a bond, these 2 electrons from oxygen and hydrogen, they will be paired after they make a bond, so become stable. Atoms form chemical bonds to achieve a stable octet elements. So of course, oxygen will be reacted with to hydrogen in order to have 8 electrons around the cell. A stable octet may be achieved by an exchange of the electron between the metal and non-metal, like NaCl, right? NaCl, Cl has 1, 2, 3, 4, 5, 6, 7 around it, and in valence, and it has 1. So as you know, this will be transferred here. Now you have 8 electrons around Cl. And if you go to the previous orbit, it is 8 electrons. So both of them achieve the octet. Right here, because this is ion, is non-metal, it is going to be ionic and they transfer. A stable octet of element may be achieved by sharing electron, like this one. You share electron here and here. The sharing of element result in covalent bond. Of course, this covalent bond here is ionic bond. So here is the Cl2, you know that these 2 electrons shared between that. NaCl, if you transfer electron from Na to Cl, of course, going to be 8 electron around that. And you know, you need to put in a bracket. Positive means it's lost 1 electron. Put a bracket, negative means it's gain electron. And it should I explain that to you. So HF and F2, I believe, is it just sharing electron? OF2, same thing. O2F2. For O2F2, you know, oxygen, we have 1, 2, 3, 4, 5, 6 electron, right? We have another oxygen. 1, 2, 3, 5. And between these two, you share electron between that, but we have F as well. 1, 2, 3, 4, 5, 6. It has 7 electron. And here is another F. I can put that there. 7 electron. Actually, maybe I just erase them. Erase something here. I put this paired electron to down there here and one paired here because I want to share it with that. This share with that. So this is sharing with that and this is sharing with that. Going to be OF2. Especially it is look like that. And we here I can use these loose structures. So here again Mg. For Mg we have 2 valence electron. If you want to do it the electron configuration of that energy configuration, energy level diagram, we did discuss that before. The same thing for Na. This is we have a 3 lone pair here, and here is 2 lone pairs there. And we did discuss the shorthand of how do you write that. Here write the electron configuration, draw the Lewis symbol for each of the Lewis atoms. So I believe this is very clear. You can do that. So here is 1, 2, 3, and 4, 5. You can do it as classwork. This is page 227. Now, sometimes we have an ionic polyatomic ions. How do we do that? For example, N is NO3 negative. Let's just do that. NO3 negative. I know I'm going to be central. Why? Because it's just one of them. 2, 3, 4, 5, right? And I have 3 oxygen. 1, 2, 3, 4, 5, 6 electron here. 2, 3, 4, 5, 6 electron here, and I put another oxygen here. 1, 2, 3, 4, 5, 6. Okay. We know that you have a negative, right? You have a negative, means you have an extra electron. Oxygen is more electronegative than N, means it's attract electron much more than N. That's why this negative will go to the oxygen. So we have like that. And if this is lone pair, will make a bond between the electron here, nitrogen. So for this oxygen, these two will make now what happened to that? What happened? One of the electron will come here, and these 2 electrons will be shared in empty space. I'm gonna clear that first. This electron move here. Now we have an empty space. This will be shared in this empty space. Just put that to make it. If you see, we have a single in oxygen. We have 3 lone pair around that. This is that one, 3 lone pair. And we have a single bond with oxygen. This is a single bond oxygen. Here has a 3 lone pair. And here is double bond with, and it's a double oxygen is a 2 lone pairs. Is this one. And I need to put that in a bracket because it is an atom with a negative charge. You have to put in a bracket and put the negative charge here. So here is NH4 with same thing. So is N as 1, 2, 3, 4, 5. And hydrogen. Okay, so since this is plus, means you need to, here is positive charge, right? You need to take away electron. So the hydrogen lose electron much more better. So N is more electronegative, right, than H. Means H is the one that tend to lose electron more. That's why we have to take away 1 electron from this hydrogen. Okay. We take an electron from hydrogen because this is positive charge. Then these 2 electrons will be shared in this space. It's gonna single bond. These two make a bond, these two make a bond, and these two make a bond. We have four single bond around hydrogen, as you see here. But I need to put that in the bracket to make sure I said need to take away electron because this is a positive charges. Okay, so let's just erase that. Now let's just do SO3. So S is central. 1, 2, 3, 4, 5, 6. And then we have 3 oxygen. 1, 2, 3, 4, 5, 6. Here. 1, 2, 3, 4, 5, 6. Another oxygen. 1, 2, 3, 4, 5, 6. Okay, so this is clear. This lone pair, this lone electron will come and make a bond with this, and this will make a bond with that. Now, what happened here? This electron will move here, and you have an empty space. You can share these two electrons in that empty space. Same thing. This electron move here, and you have an empty space, and you share. So I'm gonna erase that and move them. So this electron and this electron need to be moved here, and that was here. It moves here. Now this is empty space, so I can share that with this empty space. This is single bond, and I share this one with this empty space here. Now we have 2 single bond, 1 double bond with oxygen, as you see here. Now here, number 10, you can do